How do you build a precision firearm, flawless in performance, manufactured in minutes, and inspected down to the micrometer? In today's world, guns aren't just crafted by hand. They're built by automated systems, robotic arms, and AI-driven inspection tools. The factories behind the biggest names, Glock, Sig Sauer, Beretta, Smith & Wesson, have evolved into high-tech production ecosystems where consistency and safety come from machines, not manpower. But how exactly is a modern handgun made? What roles does robotics play in assembly and ballistic testing? And how does a factory produce thousands of firearms while meeting the strictest safety standards in the world? Do you want answers? Watch the full video to get them. The journey of every modern firearm begins with raw materials, steel, aluminum, and polymer blocks. But turning those into precision-engineered gun components takes more than craftsmanship. It takes automation at a near microscopic level. In the factories of global manufacturers like Glock, Sig Sauer, and Smith & Wesson, production starts inside fully automated machining centers. Here, CNC machines, computer numerical control, operate with tolerances measured in microns, thinner than a human hair. These machines carve out barrels, slides, triggers, and frames with flawless repeatability, 24 hours a day. There's almost no manual intervention. Robotic arms move each part from station to station, cutting, drilling, milling, and polishing in a continuous, coordinated flow. Sensors track tool wear in real time, ensuring that even after machining thousands of parts, every surface cut remains just as sharp, clean, and precise as the first. For polymer components, high-pressure injection molding systems work with robotic pickers to form and transfer frames onto the machining line, where holes, channels, and guide rails are milled with the same robotic precision. The result? Perfectly uniform parts, ready for assembly, with no human handling, contamination, or dimensional drift. In these facilities, every variable, temperature, vibration, material hardness, is monitored by smart control systems. If a drill bit dulls or a calibration shifts by even a fraction, the system autocorrects or halts the process until the issue is resolved. This level of precision isn't just impressive, it's critical. Firearms are mechanical systems under extreme stress. If a barrel is just slightly misaligned or a slide is machined a hair too tight, performance suffers, or worse, safety is compromised. Automation ensures that every gun starts with perfect geometry, built at scale, and ready for seamless integration on the next stage of the line. Once the components are machined to perfection, it's time for them to come together. And in the world's most advanced gun factories, that assembly process is almost entirely automated. Unlike traditional lines where technicians manually insert pins, springs, and safeties, today's top manufacturers rely on robotic systems to assemble firearms with mechanical precision and zero margin for error. At this stage, each part, whether it's a frame, slide, or firing pin, is loaded into a modular assembly cell. These are tightly choreographed environments where robotic arms and pneumatic tools work in sync to install complex components. Trigger assemblies are inserted and torqued to exact values. Slide rails and recoil springs are aligned with micron-level accuracy. Firing pins and safeties are placed using robotic guidance, reducing the risk of misalignment or mechanical faults. What makes these lines truly advanced is the integration of smart sensors and vision systems. Cameras scan every component in real time, checking dimensions, part orientation, and surface finish. If a part is slightly out of spec or even placed upside down, the system halts and alerts operators instantly. In some lines, robotic arms themselves make the correction on the fly without stopping the entire process. Every step of the assembly is monitored, logged, and traceable. Each station communicates with the next, forming a closed-loop system that guarantees consistency across thousands of units. This digital traceability isn't just for efficiency, it's crucial for compliance. Firearm manufacturers must meet stringent regulatory standards, And automation ensures every gun is built to spec and fully documented for quality control audits. Another advantage, flexibility. Modern lines are designed to reconfigure in minutes. A single robotic cell can switch between different handgun models with minimal downtime, adapting to changing production demands. Whether it's a compact concealed carry pistol or a full-size duty firearm, the automation adapts flawlessly. In short, these aren't traditional assembly lines. They're smart production ecosystems where robotics, sensors, and software come together to build high-performance firearms faster, safer, and more consistently than ever before. Once a firearm is assembled, it's not ready for shipment just yet. First, it must prove it can perform under pressure, literally. In the most advanced gun factories, ballistic testing is no longer a manual process. It's handled by robotic systems operating inside reinforced, soundproof test chambers, where every trigger, pull, recoil movement, and pressure reading is tracked with digital accuracy. Each handgun is loaded by an automated loader and test-fired remotely. The firing system mimics a human grip with mechanical precision, applying exactly the right amount of force and angle to simulate real-world use. This removes any human inconsistency, allowing every firearm to be judged under identical conditions. The data collected in this process is extensive. Muzzle velocity, cycle speed and ejection timing, chamber pressure and recoil forces, trigger pull weight and reset behavior. These variables are instantly captured by high-speed sensors and analyzed by custom software, comparing performance against strict benchmarks. If even a single parameter falls outside tolerance, the weapon is automatically flagged, removed from the line, and sent for diagnostic inspection or rework. More than just quality control, this phase ensures safety and durability. Firearms that pass these tests are certified not only to function, but to withstand the mechanical stress of hundreds, even thousands, of real-world firing cycles. This process also generates a digital fingerprint for each weapon, an internal record of how it performed during live testing. In many factories, this data is stored alongside the serial number, forming a traceable performance history that can be accessed years later. And because it's all automated, this testing happens at scale. Factories can validate hundreds of firearms per day with no interruption, no downtime, and no risk to human testers. In the age of high-volume firearm production, robotic ballistic testing ensures that precision doesn't end at assembly. It's verified through live fire, one round at a time. Modern firearm manufacturing isn't just about precision, it's about building trust. That trust depends on safety, regulatory compliance, and consistent quality. And automation plays a critical role in all three. By removing human error from critical steps, machining, assembly, testing, automation significantly reduces the chance of defects or malfunctions. This isn't just important for performance, it's essential for user safety. Whether it's a law enforcement officer, a sports shooter, or a civilian relying on a firearm for protection, there's no room for failure. Factories are also under increasing pressure to comply with strict national and international standards. Automation systems log every torque setting, every test result, every calibration in real time, creating a digital audit trail. This ensures full traceability for regulators and makes it easier to isolate and address potential issues quickly. And then there's efficiency. With automated lines, manufacturers can run 24/7 with minimal downtime. Machines don't need breaks, don't get fatigued, and don't make mistakes due to distraction. That means higher output, lower scrap rates, and faster fulfillment of growing demand without sacrificing quality. In many facilities, automated systems are also used to improve worker safety. Employees are no longer exposed to high-decibel test chambers, airborne particulates from machining, or repetitive strain injuries. Instead, they oversee processes from control stations, interacting with the system when needed, but never placed in harm's way. Automation doesn't just change how guns are made, it transforms the entire philosophy of firearm manufacturing, from handcrafted to hyper-precise. from labor-intensive to machine-optimized, from reactive to proactive. From raw steel to test-fired reliability, today's firearms are no longer built on tradition alone. They're built with code, robotics, sensors, and real-time data in factories that prioritize accuracy, safety, and scale. The world's most advanced gun manufacturers aren't just keeping up with demand. They're redefining the standard for what a firearm can be, down to the micrometer. If you found this video insightful, hit that like button, subscribe for more deep dives into high-tech manufacturing, and let us know in the comments, what surprised you most about how guns are made today? This video is produced by Automate, the leading platform connecting robotics and automation talent with the companies building the future of smart manufacturing. Visit automatedeal.com to explore more and stay ahead in the world of industrial innovation.